Hello, everybody. It's Vince Marino, and welcome to my Lunch and Learn with Vince. I've got a couple of really great guests today. Arjun Shanmugam is Business Development Manager at Industrial Flow Solutions. He's bringing strong background in the industrial engineering and manufacturing and new product development. He holds a master's degree in industrial engineering and a bachelor's degree in electronic and instrumentation. Throughout his career, Arjun has excelled in various roles across manufacturing and business development, combining technical expertise with strategic insight. At IFS, Industrial Flow Solutions, plays a pivotal role in driving innovation and sustaining the company's leadership in the water and wastewater industry, which, by the way, is near and dear to my heart. And also, I have Ed Nickerson. He is a sales engineer and manager at Gustavo Preston Company. Ed has over 10 years of experience in pump design, installation, and retrofitting pumping stations, demonstrating a commitment to delivering innovative solutions in the field. Ed's a member of American Society of Plumbing Engineers, ASPE, in Connecticut and Massachusetts, and provides engineers with valuable insight into the latest advancements in pump technology. And with that, I wanted to just say welcome, gentlemen, Arjun and Ed. Thank you. As you may already know, you are a near and dear customer of ours here at Empowering Pumps. In fact, you're a advertising partner. So I'm going to show off your partner hub here. I welcome everybody that's listening to come on board to empoweringpumps.com and check out the Industrial Solutions Partner Hub. Tells you a little bit about the company, has an OverWatch brochure here and a couple of products here. So with that introduction, welcome Arjun and Ed.
Thank you. Thank you, Vince.
It's great to see you guys. One of the goals I have here with the Lunch and Learn with Vince is to capture tribal knowledge. I think it's important. I talk to people of various ages, and they confide in me that I've got all this head knowledge, and I've retired. Some people have retired two, three times, and they've been hired back because the people are starting to realize that what they have up here is difficult to put down in writing. Certainly not always something that people remember, but certainly if we can put it on video, maybe someday this will help somebody in the future. So with that, I just wanted to start off with a welcome and just tell me a little bit about why we're here. What are we going to talk about?
Sure. So we're here to talk about OverWatch direct inline pumping system. So I'll go over kind of a brief overview about the system. So OverWatch is a direct inline pump system, meaning it lifts effluent at the point of entry. So what we see in the industry today, the most common type of pumping is you have an in-suction style or submersible style pumping, where it's more reactive to the environment. So there's a wet well, you have pumps within, and effluent is collected as a collection point, and via floats or via transducers, a pump is signaled to move that effluent out. With this type of technology, the pump suction is essentially flanged directly to the invert, which is the point of entry of your effluent. So none of the effluent is actually exposed to the atmosphere. It comes right within the piping of your invert into your pump and straight out to the main sewer line or the main sewer discharge of the building. So it helps provide a clean environment, a safe environment for personnel working with the equipment, and as a by result, also eliminates any odors, smells, or gases that you typically find in wet wells. Um, and
Okay.
and in today's lunch and learn, we're going to talk about a retrofit installation of a failing lift station that we designed with Gustavo Preston, and Ed was the chief consultant for this project. So I'd let Ed kind of take over what kind of problems the universities faced, and our design intent to kind of change this from a wet well to a dry well, essentially.
Excellent. And while Ed continues on, I'm going to have this in the background. I believe this is what we're talking about, Ed. So go for it.
So the university struggled maintaining the wet well that's currently existing. It does pick up kitchen waste, public and private toilets from dorm rooms, and boiler room equipment that might end up down in there. And over time, the fats and oils and greases would end up getting congealed and hardened. The synthetic wipes and rags would then kind of make a slurry mixture that the submersible pumps just weren't able to handle and discharge. So they'd get ragged up and they'd stop working. And the school would have to pay for a truck to come out, clean the pit, pay for a technician to go and lift the pump out of the effluent, derag it, pull it all apart, and clean it, and then put it back in. And the failures were happening more frequently, and they could happen at any time of day. It wasn't a matter of if they were going to break down. It was when, and was it going to be at a time where the school was occupied, or was it overnight? And the failures resulted sometimes in flooding and just a really hazardous environment. Working with the school, taking this technology to them, they really saw the benefit of not having submersible pumps and using the direct inline pumping to handle that fluid in its flushed state and get it directly into the forced main and out to the sewer collection network.
So I'm looking at the video right now, Ed, and I'm going to back it up just for a little bit here. This is you dropping the OverWatch. This is what you're talking about right here, right?
Yeah, and the OverWatch comes fully assembled from the factory after testing. And depending on the application, this one really easy. We were able to just rig it right down into the hole, right into the cleaned out basin, and ready for piping.
Right. And I saw a little bit right about here on the video. This is a good looking piece of equipment. Right here, it looks like that's the brain behind Overwatch. Am I right? Is that what actually controls things?
Correct. Yeah. So they have a Nemo4 enclosure with two VFDs and cooling, as well as the PLC that's going to control and in all the integration. And the smart sensing technology used in Overwatch goes back to the controller and establishes the P&ID algorithm that controls the speed of the motor to handle the effluent coming into the pump. And as the effluent would increase during times of showering or kitchen prep or high toilet volume usage, the motor can speed up and slow down depending on the effluent going into the pump.
Excellent. And there's a closer look at the VFD part of it. Yeah.
Correct.
So what this is a before, I'm assuming, right? And then after, my God, that is like night and day. Look at that.
Well, it goes to show, even in a wet well, the engineering concept is you need to have a minimum fluid level to maintain the motor cooling. So most submersible pumps have a 24-inch minimum fluid volume. So you have to retain that water in the wet well. And over time, what happens is that layer builds up with fats, oils, greases, synthetic wipes, and rags, and it becomes a harder, more slurry, and sometimes almost brick-like material inside that wet well. So as the fluid level decreases and it finally reaches the eye of the inlet on that submersible pump, there's just not enough torque in the motor to handle that thick slurry. So the motor will trip out on overload and get all ragged up, and then we'd have to pull it, derag it, put it back in. But even before we could put it back in, it would have to be pumped out, evacuated, cleaned and made safe and ready for another go.
Right. I saw them pulling that up earlier in the video. When you at the early part of this video, they show this equipment coming up. It just caked with almost a concrete like substance, which is indicative of fog, I would imagine.
That is
That's
correct.
exactly.
Yes.
Fog meaning fats, oils, and greases.
Yes.
So how how does it work? I mean, how I mean, I get it. Submersible pump submerged in all this effluent. It's a problem waiting to happen here. I'm pulling it up right now. I'm going to show this thing one more time. So you got the submersible pump here, just caked on with all kinds of stuff. Um, then you go over to the Overwatch product, which is just like I said, it's a beautiful, clean, sleek looking solution here, right here. What a difference, right? But how how does it work? I'm seeing two motors kind of converging into one direction here, but maybe you guys can just kind of explain how that works. If I'm flushing rags and wipes and all kinds of things, and you're going to get some clogging or slowing of it, how does it work?
So I'll start with the basic function of a wet well. Your invert is directed into the wet well where the submersible pumps will be, and fluid is constantly flowing into that wet well. So as fixtures are used, kitchen prep is done, those solids will start to accumulate in that wet well. A wet well is controlled typically by a float level control system where you have an off float, an on float, an alarm float, and maybe a high water alarm. And those floats are susceptible to getting fouled with the fats, oils, and the greases and the rags. Another failure point for that type of pumping system. Conversely, the Overwatch system is designed to collect that effluent as it's entering into that station. So, for example, I like to say handles everything in its flushed state. So, solids, rags, wipes, synthetics aren't able to collect in an amount that's going to cause the pump problems. So, as those toilets gets flushed, food prep happens, it's brought down into the collection network into the pump, and then it is pumped out of the pump into the force main. The concept behind this P&ID algorithm begins with the pressure sensor, the smart sensor technology. And as the water pressure in the inlet side of the pump starts to accumulate, gets higher pressure, there are set points predetermined in your system for on and off and to regulate. If there's a steady flow of fluid going into the system, the motor is going to run at a speed that regulates the fluid level to a desired point, and water is constantly moving away from the station. If there's an intermittent flow of water, then the pump will drive the water pressure by sucking it out to a set point and then shutting off. And then as that water pressure accumulates in the collection network again, it'll reach a pressure set point. It'll turn the pump back on. And it repeats. The lead lag function is a time-based function, and it's on motor runtime. So I believe it's 2 hours of runtime. It'll alternate to the next pump. The smart sensing technology, the system's designed to measure a couple of parameters: motor torque, motor speed, amperage. And if those parameters are outside of what's normal, it'll shut off and it'll call the standby pump on. And that pump that experienced that out of tolerance situation, it'll spin backwards. And the dip cut impeller is designed to fold backwards, and it has blades on the opposite sides of the vane. And that will chew up anything that's inside that volute. So a synthetic wipe, maybe a large solid, and other things that can be flushed down toilets and things. So
Right now,
in food prep, yeah. In
now
food
I
prep,
was
you can get some.
go ahead. I'm sorry, we're
Go ahead.
talking to each other. I was in Monsalecce, Italy, and I saw that example. And if I'm not mistaken, on the impeller, it was like an L, and it would when it would reverse, it would flip or something like that. I probably am not, but when it would go
That's
back,
actually a pretty good description.
like an L bracket, right? Kind of like that, where it would flip and
It's
then
a
be
hinged
the
impeller.
short.
That's right, Vince. So the vanes are actually hinged. So in regular operation, you've got the hinge upright, and you've got regular pumping. And when the motor goes in reverse, the hinges fall down, exposes blades, and that allows for that shredding of material within the lid of the pump. And so it does a shred cycle, what we call is a clean cycle. A clean cycle is essentially a reverse, goes for about 15 to 20 seconds, assesses the torque of the motor, understands that the torque is beyond its normal operating range, and the pump, you know, goes in reverse and it runs in full speed, trying to remove that debris that's clogged up or chop up, and it'll go back to a full stop, and then going forward and reassess the torque to see if it's within those normal operable limits. And if the torque is within the normal operable limits, pump continues to pump forward. If not, the reverse cycle happens again. The user gets an alarm stating that the pump is going into what's called a clean cycle. So you've been informed that your pump is doing all of this autonomously, without any intervention required.
So, question for you: when all this is happening, is there some type of uh, monitoring capability on my smartphone or an email? Or yeah, I'm seeing yes. So if I'm running the operation, I can be at home as the maintenance man at the university, and I can get an update as to what's going on.
That's a great question. As you can see, the last 10 years, the industry has been shifting to IIoT, which is Industrial Internet of Things. That's been a big topic. We've discussed this in the past with IFS, and how we've been adopting some of the smart technology that's available. So I'll go in as what we provide as standard is dry contacts, which are basic signals that you can let the user know about a pump failure, a failed motor, a high water alarm, anything critical to the operation of the pump or the sump itself. Um, and the next level would be a backnet protocol, right? So the backnet was predominantly used in the HVAC industry, where you have all of your equipment in the building talking to a central gateway, where you'll be able to take that information and figure out if you need maintenance for certain type of equipment, or if you have any alarm points, or any services required. So we can integrate to a building's backnet gateway via backnet card. It's done over MS over TP or IP, which is an internet protocol. Um, in the municipal market, we're seeing a lot of SCADA integration to SCADA systems. So we can essentially go into any of these avenues depending on what the infrastructure in that specific location or the end user's request. But some of the most common on the commercial industry has been dry contacts, and backnet. You were talking about getting signals on your phone. That is typically done with a cellular gateway, and that is also offered with IFS, OverWatch. And the idea is that if you have a cellular connection at your location, we will provide a ancillary box that essentially collects all these signals and sends you the signals via text message, or you can open up in your browser and look at this real time.
Wow, that's fascinating. So you mentioned HVAC too. It'll integrate with all of the different.
The
Essentially,
communication, yeah, the communication protocol on BACnet is fairly generic. So if we're provided with, or if we're engineering a system, we do want to know what the building communication protocol is, and that BACnet card can be programmed to accompany that. So if it's a JCI, a Siemens, a Schneider, or some other building automation system, we
right.
can match that protocol.
Interesting. So that's a fascinating story. Have you got any others like this where you've gone in and Arjun, other universities or other facilities, and what do you got on the horizon? Are you working on anything now? I mean, tell me a little bit more.
So I would say, almost close to 60% of our install base here in the United States has been on the off-market side, and this comes from applications where existing pump systems have failed. So we're not getting the easy applications. Overwatch has been subjected to some of the harshest applications. Um, wet wells where there's clogging that happens on a frequent basis due to wet wipes, due to rags, smell issues. So we're constantly working on projects across the country, and in airports, in hospitals, mixed use facilities. That's really where the Overwatch as a product fits the best. High density of people, and where there's a lot of issues with clogging, smell, or not having enough room to build a wet well. Because having a direct inline pump system like the Overwatch, you only require 24 inches below the invert to be able to install this above ground. So we get requested again. This is more on the commercial side, but on the industrial side, meat processing plants. We've got different aspects of food and beverage industries that use us. Um, Boiler washdown where there's caustic, there's chemicals used in clean in place solutions that go within the piping and it's not exposed outside. So there's a lot of benefits in how you use the system, and the type of end users that use the system.
And Gustavo Preston is the New England rep, and we've had a lot of experience now over the year and a half it's been approved here in New England. And to Arjun's point, hospitals where there's a high density of people have been adopting the technology pretty quick.
Yeah, I can see
Another
that.
important, another important aspect I missed, Wins, is something that we've been discussing a lot on the ASPE network, which is the Plumbing Engineers Association. Um, the biggest problem the industry faces is, we touched upon fats, oils, and greases, right? Kitchen waste. Um, and the Overwatch direct line pump, the way it's designed is it takes effluent at the point of entry and it moves it in real time. There's no stagnation or, of fluid. And this is what builds up your fats, oils, and greases, right? So as they build up, they almost build up a layer, and it's hard to pump that down. So just changing the way we apply a pump solves this problem in the industry. This is a huge issue,
Yeah.
especially in mixed use facilities where you've got, on the first floor, you've got um, grocery stores, restaurants, and then floors three and above, it's residential. So you've got a lot of buildings like this coming up that have issues where we can use the direct line pump overwatch system to either pump upstream or downstream from an oil water separator. And you're doing this in a complete closed loop fashion. We've also introduced a hot water flush, which is a flush system that's piped directly into the suction of the pump that allows the end user to turn on a hot water valve and run that valve, for about 30 to 45 minutes, degrease the entire system, and then and continue pumping. So that way, there's no buildup within the piping or within the pump system itself.
Is that an automated process or manual?
It is an automated process, and what's really convenient in the university settings, we all know that some of those buildings go dormant for a month, 6 weeks at a time during, in between semesters or school breaks. So if it is a kitchen area or an area that has um, food prep, that forced main could be stagnant for 3, 4, 6 weeks,
Yeah.
and those solids can settle out. The nice thing about the smart sensing technology is if there's artificial head, because that forced main has been restricted, as the water goes into the Overwatch pump and that sensor senses it backing up, that VFD is going to automatically increase its speed to overcome that artificial head. And with the hot water flush valve included in that system, you can introduce that clean hot water and pump that through and clear away that artificial head and then get back to normal function.
You know, that actually makes sense logistically. You're probably near where hot water is generated too. I mean, you're kind of in that whole area at a university. It's kind of, you know, you've got your heating and air conditioning and all that is nearby. So logistically, you could create a pipe right there with the hot water. And I mean,
In our application at this particular university, the hot water heater was just outside of the basin. So 3 feet of pipe and a valve.
yeah, I can't believe that this hasn't been thought of sooner. So kudos to IFS. I'm going to show
I
you a
don't think
website.
they take credit for the design.
Who takes credit for the design? Who's that? Who
ahead.
gets credit?
So this actually was a request from an engineering team out of New York City, and we were working with a grocery chain, and they were concerned about the fats, oils, and greases, and it was a request to see if we can have some kind of an injection system, and then it just came off of a discussion on a Teams meeting, and we went back to the drawing board, looked at different options. And given that our system is completely closed loop, it's flanged, allows us to add an extra spool piece on the suction side with a 3/4 inch tap, run a valve to it, and and make this happen. So,
Right. Well, this has been enlightening to say the very least, and you obviously got a fine solution to what has been a chronic problem over the years. I mean, I myself have called on universities in the wastewater treatment area, and I'm familiar with all the various challenges they have, and a majority of them do have a downhole type, you know, submersible of some sort or another. So I've seen it myself. So I got to give you props and kudos for coming up with a very unique system, the OverWatch system. You got anything else coming up in the future? Are you going to be at any shows? Are you going to ASPE? Are you going to be?
we're going to be, yeah, we're going to be at ASPE. Excited to be displaying a live demo unit. I'll be doing a lot of the live demos. So, really excited to be meeting our MEP engineering group as well as contractors and people from the industry. Empowering Pumps is going to be there. So, feel free to stop at our booth, and I'd be happy to give you a live demo and show you the operation of the system. So,
Thank you very much. Okay, well,
I'm hoping we can get together in the spring and do an ASPE event up here in Massachusetts.
that'd be awesome. You guys keep me posted. Ed and Arjun, I just want to thank you for hopping on the Lunch and Learn and give me a quick download of what's going on with Overwatch and Industrial Flow Solutions. Personally, I've enjoyed meeting a bunch of great people over there, from the president all the way down. I've met everybody at the company, and you guys are a fine group, and want to just thank you for sharing a little knowledge. Hopefully, this is going to help people. You know, again, you got clogging problems with a submersible. This may be the answer. So, thank you so much.
thank you, Vince. Appreciate
Thank
the
you.
opportunity.
Nice to meet you.
It was my pleasure, guys. Thanks.